For centuries, the camel has defined life in the desert. It is the only mammal capable of an extreme feat of endurance.
It can ingest over 1/3 of its body weight in fluid in a single session, surviving days without a drop.
The surprising origin. 40 million years ago, the ancestors of all camels and llamas roamed the vast plains of North America.
Its earliest ancestor, Protolopus, was no desert titan. It was a forest-dwelling creature, barely larger than a rabbit.
The family tree split. One branch moved south to the Andes, evolving into the llama and alpaca, high-altitude specialists. Driven by climate change, the ancestors crossed the Bering Land Bridge, leaving their birthplace for the harshness of Central Asia. The core of their resilience: oval-shaped red blood cells. These resist rupturing when water is lost or rapidly gained.
This shape allows blood to flow, even when thick from dehydration, preventing circulatory shock and organ failure.
From the freezing Gobi to the scorching Sahara, camels adapted not just to drought, but to the wildest temperature swings on Earth.
They allow their body temperature to fluctuate wildly, storing daytime heat instead of sweating to maintain a constant temperature.
This thermal inertia is key. They only start sweating when others would already be in crisis, conserving huge reserves of water.
External features also aid survival. Dual-layered eyelashes protect their vision from the constant assault of desert sandstorms. When core temperature soars, a complex network of blood vessels cools the brain, using cooler venous blood from the nasal sacs.
The nose, not only a cooling mechanism, is a dust-proof seal, allowing them to breathe freely, even in the blinding chaos of a haboob.
Every drop is sacred. Their kidneys and bowels are biological reclamation centers, extracting maximum water before waste.
The iconic hump evolved as a massive store of energy, fat, which provides metabolic water and fuel when food is scarce.
The hump is not a water tank, it is fat. When metabolized, it releases both energy and significant amounts of water vapor.
Their feet are living snowshoes, evolved to spread the colossal weight and traverse the softest desert sands effortlessly. They consume the toughest, driest, most thorny plants the desert offers, utilizing food sources others cannot touch.
Rapid rehydration is fatal for most mammals, but the camel's flexible cells prevent water from flooding and bursting them.
The dense outer hair acts as a reflective shield, preventing solar radiation from directly reaching the skin.
They digest cellulose using a complex 3-part stomach, maximizing nutrient and water extraction from poor-quality feed.
The two species represent two specialized paths: the dromedary optimized for heat, the Bactrian for the bitter cold of Central Asia.
Most mammals lose blood volume first. The camel protects its circulation, drawing water from its cells to preserve the plasma. The pads allow them to rest directly on 70 GC sand without injury, another testament to their physical durability. The first camels were browsers, not grazers, lacking the extreme tolerance that would define their later survival.
Despite their fame, the wild Bactrian camel is critically endangered, facing habitat loss and poaching in its native range. The efficiency of their metabolism is crucial. Every calorie must count in the energy-poor landscape of the desert. The oasis is the reward for survival. Here, the internal biological systems recharge.
Their split, prehensile lip is a tool of precision, allowing them to navigate the defenses of thorny desert flora.
Their renal system is an evolutionary masterpiece, creating highly concentrated urine to retain every precious milliliter of fluid.
The struggle begins at birth. Calves are vulnerable, relying on the mother's water-conserving milk to survive the initial heat.
Domestication amplified these traits. Humans relied on the camel's biological perfection to open up trade routes across continents. Their vision is sharp, able to spot the faintest signs of water or vegetation miles across the featureless expanse.
The evolution of the footpad from a hoofed ancestor is the clearest physical record of the shift from forest to sand.
This unprecedented thermal tolerance is a unique key to survival, eliminating the need for constant evaporative cooling.
The hump is the ultimate measure of their sacrifice. Its deflation signals the extreme resource management required for survival.
They do not panic. The instinct is to lower the center of gravity and endure, relying on their physical shields.
The spitting is a form of non-lethal deterrent, a quick, messy signal that the animal is highly stressed or threatened. Size was also an early adaptation. Giants like Titanotilopus showed that the family always favored height and bulk.
Their distinct pacing gait, though awkward for some riders, is energetically efficient for long-distance, low-speed travel.
Camels can tolerate high salt levels, a rarity, allowing them to drink brackish water sources when fresh water is unavailable.
The lips are essential tools, navigating the hostile botanicals of the desert floor with precision.
The evolution of the camel is a testament to the power of relentless pressure, forcing life to find solutions at the edge of possibility. The metabolic reaction that burns the hump fat provides a continuous drip of internal fluid, crucial during long fasting periods. They are slow grazers, deliberately consuming small amounts of food, maximizing the yield from every bite.
By concentrating fat in the hump, the rest of the body can radiate heat efficiently, accelerating the cool-down phase at night.
From caravan to camel racing, its genetic superiority ensures its relevance even in the oil-rich deserts of the modern age. Camel milk, a highly nutritious blend, provides the calf with the necessary energy and fluid for its early trials.
Movement is optimized for the cooler hours, another behavioral adaptation to minimize heat gain and water expenditure.
Even the breath is recycled. A countercurrent system in the nose traps water vapor, returning it to the body with every exhale.
From a short-necked browser to a long-limbed giant, the camel's form was shaped by the height of desert forage and heat avoidance.
The loss of ancestral forests pushed them to evolve. Only the toughest, most water-efficient survived the arid landscapes of Asia.
For man, the desert is a constant threat. For the camel, it is a managed challenge, overcome by physiological mastery. It is the combination of these three biological miracles that makes the camel the supreme engineer of water conservation. They possess the wisdom of the long road, a quiet confidence born from millions of years of surviving the impossible. Their habitat is the wasteland. Their domain is the heat. Their survival is a blueprint for endurance.
They are the ships of the desert, built not by timber and canvas, but by the slow, unyielding hand of evolution.
Every slow breath is a calculated exchange, balancing the need for oxygen with the absolute conservation of water.
A legacy of water. The ultimate triumph of life against the driest odds.